Good morning and welcome to the second day of the conference. It is our honor to address the gathering once again as we continue our exploration for the latest advancements and innovations. Yesterday, we witnessed thought-provoking presentations, insightful discussions, and exchange of pioneering ideas from researchers and practitioners around the globe. As we embark on today's sessions, we look forward to 3 technical sessions along with a keynote address. We encourage you all to pose questions and share your perspectives. Your contributions are invaluable in enriching the discussions. Now let us commence today's proceedings by introducing our session chair, Professor Fanindra Kiran Chaganti from BITS Pilani, Hyderabad, and co-chair, Dr. N. Madan Mohan Reddy from Anurag University.
Our session chair, Professor Fanindra Kiran Chaganti, is currently working as Associate Professor, Department of Mechanical Engineering at BITS, Hyderabad. He obtained his PhD in Mechanical Engineering from BITS Pilani, India. He did his Masters in Manufacturing Systems Engineering, BITS Pilani. With his research acumen, he got multiple government and industrial sponsored projects of worth around 60 lakhs. His work is recognized through his quality publications in 9 international national conferences. He has 3 book chapters and 30 plus quality journal publications. We welcome you, sir. Our session co-chair, Dr. N. Madan Mohan Reddy, sir, currently working as Associate Professor, Department of Mechanical Engineering, Anurag University. He is also serving as Associate Director, Innovations at Anurag University and Coordinator, Center for Research in Digital Manufacturing, a Center of Excellence in Anurag University. He obtained his PhD from BITS Pilani under the guidance of our session chair. Thank you, sir. We welcome you. Now let us start the proceedings of today's technical session. Paper by Dr. S. Jesh Kumar with paper ID paper ID 22 titled Teaching Learning Based Optimization of Ultrasonic Welding Parameters for Enhanced Copper Joint Strength, a comparative study with Taguchi and GRA. Sir.
Good morning to all. Myself, Dr. Jash Kumar Siddhani from Mechanical Engineering Department, Anurag University. And now I am here to present our paper on teaching learning based optimization of ultrasonic welding parameters for enhanced copper joint strength, a comparative study with Taguchi and GRA. Here, the ultrasonic welding is used for the metals and non-metals also for joining very thin size sheets or materials. Whether it is also used in the biomedical industries and fabric industries also to joining the thin materials. So here, the ultrasonic welding is a salt shed joining process widely used in industries such as automotive, aerospace, and electronics for high precision, minimal thermal distortion, and short cycle times. And the challenges are optimal parameter selection to maximize the weld strength between the two joining materials. So here, if you see the industrial use in the automotive sector, we are using it is almost 35%, and in electronics 25%, and medical devices 20%, and 10% in the packaging industry and consumer industry it will be 5%, and aerospace 3%. Wherever the minimal thickness of the joint is very minimal, then we are going to use the ultrasonic welding. And here for my paper, for our paper objectives are optimize ultrasonic welding parameters. Here the parameters are pressure, weld time, and amplitude. And here we optimize it by using the teaching learning based optimization. And I compared the TLBO with the Taguchi method and GRA. And the experimental setup, it will represent the experimental setup. So here I'm joined the copper sheets of length 100 mm and width 50 mm and thickness of 1 mm. And welding machine has the specifications of 20 kilohertz ultrasonic metal welding machine with 3.6 kilowatt output power. And the key parameters are the pressure, weld time, and amplitude. And here for designing, I used the Taguchi technique, and I took the 4 levels for Taguchi. Pressure in bars, that is 2.5 bar to 4 bar, and weld time in seconds, 2 seconds to 3.5 seconds, and amplitude in micrometers, 30 micrometers to 60 micrometers. And here I took the Taguchi as L16 orthogonal array. So these are the L16 orthogonal array. I set up the external setup. And here the auto intake is I am comparing the TLBO with the regular Taguchi method along with the gradation analysis. And if you observe the key points in the Taguchi method, reduce the number of experiments. So you're not able to, I mean, not do all the experiments in the region. So here it will reduce the experiments and assumes linear parameter interactions. So it is only in one directional. Gradation analysis, it is multi-objective optimization and require complex data normalization. We need to do normalization for each and every experiment. And in here, you applying the teaching, the new method, that is teacher learning based optimization, efficient for non-linear problems, requires no algorithm specific parameters. And the points in the teaching learning based optimization, it is nature inspired automation algorithm based on the teaching learning process, which mimics the way human learn and teach. It is a population based algorithm that optimizes solutions through two primary phases, teaching phase and learning phase. And the key phases of TLBO, that is teaching phase, the best solution in the population acts as a teacher. The other solutions are updated based on the teacher's knowledge. Students' solutions are modified by random influence from the teacher, leading the better solutions. This phase helps in global exploration and diversification of the population. Learning phase. Each student learns from randomly selected peer in the population. The update is also influenced by randomness, promoting local search and refinement of solutions. The phase introduces exploration, simultaneously increasing the diversity of the population and helping to avoid temperature convergence. So the advantages of the TLBO is relatively simple to implement because it does not require complex operators like crossover and mutation in genetic algorithms. And it uses basic operations like random number generation and difference between solutions, making it computationally efficient. No gradient information required. TLBO is a derivative free optimization method, making it suitable for complex nonlinear or noisy objective functions. And it is robustness. Here, in the TLBO algorithm, I consider the population size as 30 and number of iterations as 100 and pressure range as 2.5 bar to 4 bar, which I given in the earlier, and weld time as 2 seconds to 3.5 seconds, and amplitude, and stopping criteria maximum number of iterations as 100 iterations. And it is the flowchart of the TLBO algorithm. So it defines the first of all the teacher phase, and then it will be student phase. I'm not giving the brief sub-best procedure here. This is the basic algorithm, and I done this algorithm in the Python. And the results. So after doing the Taguchi method and gradation analysis and TLBO for the weld strength of the joint, I took the three optimization techniques, and the optimal parameters found out by the TLBO is 2.5 bar, weld time 3.5 seconds, and amplitude 60 micrometers, and achieved the weld strength of 27.9 Newton per millimeter square. And if you observe, the Taguchi is giving around 22 to 23 Newton per mm square, and GRE is giving the 25 plus, I mean 25 point change, and it is and TLBO is giving the 27.9 Newton per mm square. And If you see the baseline of the pressure for the TLBO is 3 bar, 2 seconds, 40 amplitudes, and it is giving the minimum strength, that is 17.5 Newton per mm square. And in the optimized or TLBO, we'll get the pressure of 2.5 bar, 3.5 seconds, and 60 amplitude. It is 27.9 Newton per mm square weld strength. And it is a plot of the convergence plot of TLBO algorithm. So the maximum is converged at the 40, sorry, we'll getting that maximum at the 27, that is showing in that graph. And influence, the parameter influences on the weld strength. So if you see the weld, I mean, in the weld strength, we have we'll get the best, I mean, the weld strength is influenced by the pressure at a percentage of 39.6%, and weld time, that is 32.4%, and amplitude 39.6%, and error is 4.2%. And I should represented the iteration plots here. These are data points which are generated in the Taguchi. So statistical validation, to check the results, we used the ANOVA results for statistical validation. So in the validation, we got the p-value that is less than 0.05. The p-value of the pressure and weld time and amplitude all are getting the less than 0.05. So conclusions: the TLB achieved superior weld strength, that is 27.9 Newton per mm square. That is when comparing with Taguchi 22.5 Newton per mm square and GRA 24.8 Newton per mm square. So highlight the TLBO effectiveness for non-linear parameter optimization is very more. So the future scope is explore hybrid optimization techniques, extend research to different materials and welding processes, investigate multi-objective optimization balancing, weld strength, energy consumption, joint quality. And this is my presentation. Thank you. Any question?
So I think one minute is remaining. Okay. So you finished in 9 minutes. Okay. Thank you.
Thank you,
Sir, thank you, sir.
Jash Kumar,
sir.
Jash Kumar. So, well presentation. I have few questions.
Yes, sir.
How can we compare Taguchi with PLBO? The applications are different, right?
In the Taguchi, you are only taking only one, output, sir, like weld strength.
So, what are the multi objectives here in this one?
Here I took, actually Taguchi, here I took only one objective, sir, actually, weld strength.
Okay.
But even for one objective, I represented the thing, same thing.
No. Only weld strength is the single objective, right?
Yes, sir.
So then where are the multi objectives I'm asking? Generally, we go for these optimization algorithms for multi-objective function. If it is a single objective, generally we go for Taguchi, right?
Yes.
So we cannot compare these three generally. If you are comparing with like ant colony optimization or something,
Yes,
then it is valid. Experimental, I don't think we can compare, but it's a good work.
Right. Thank you, sir.
Okay, thank you, sir. Sir, I think any other questions from the audience?
Minimum value, man. Minimum strength. The minimum strength. To get the minimum value, these are the parameters, man. The weld strength for the minimum is 17.5 Newton. For experiment, by experiment, sir. We got the experiment and we done with the TLBO also. We compared the results. We didn't take any here we didn't mention any temperature parameters, right? I maintained the recrystalline temperature itself. Same, sir, recrystalline temperature. Then only it will be joined.
I think I have only one question. Like, so what is your before thought process of comparing these two, DLBO and also?
Actually, I'm very basic level in the TLBO. Just I done some experiment by single objective, but future I will do for the multi objective. that are generated by the TLBO. That optimized value which is given from the TLBO. We are not generated, but we compared with the experiment. Any other questions?
Any other questions from the students, right? MTech.
Okay, thank you. Thank you.
Thank you. Thank you very much.
Next paper is by Mr. Lunavat Naik, sir, with paper ID 23, titled Effect of Square Tool Pin Profile on Microstructure and Mechanical Properties of A8011 Butt Joints in Friction Stir Welding.
Good morning, one and all. Today I am presenting paper on effect of square pin tool profile on microstructure and mechanical properties of aluminum alloy 8011 joint in friction stir welding. The abstract is there. So in the abstract is there the square pin profile, how it is impacts on that is a microstructure and mechanical properties at various studies, characterizations we studies about that one. In this parameters we are going for that. And then we taking the sum of the parameters like that is the spindle speed, weld speed, and load tilt angle. From this, also some of the studies we can taking that like the mechanical properties, strength, and impact strength, hardness. So material selection 8011, we are taking for that. There is a good properties to compare to the weight and strength ratio. So that's why in this material we are using that is a aviation industries. From this material, the main compositions are iron and silicon. So this is a 8 series advanced material we are using, that is a aerospace industries. Tool material. So in generally tool material is using that is a H13 steel, and then in this case we are using that is a titanium and aluminum. So the 25% of aluminum material we are using that one. So because of this material is selecting, but that this is a good temperature resistance and corrosion resist of the material. So compared to the melting temperature of the aluminum and tool metal is very different. So that's why we are selecting this material for the friction stir welding process. Right here we are taking that is a some parameters on base of that is a speed. 9 experiments we done by using this one. These are all weldings are getting that is a very good quality welds. So square pin profile is a the mixing ratio of the flow is a very good it compared to the circular pin profiles. That's why this pin is selecting for this friction stir welding. And then diameter, the design of the tool pin, that is shoulder is taking that is a 18 mm diameter, and then pin diameter is taking that is a 6 mm, and the tin depth is taking by 4.9 mm. So material thickness, base material thickness is actually 5 mm thickness. So 1 mm we like less 1 mm we are taking that one. So due to of that, the friction stir will goes to good at below the recrystallization temperature, the welds gets good quality. And this is the experimental setup, and these are the parameters considering like that. That is a rotational speed is taken that is 900, 1350, and 1800, and weld speed is taken that 16, 26, and 36 mm per minute, and tool is taken this one. The combination of experiments taken by that 900, 16 weld speed, and 26 and 36 weld speed is taken by this one. And the next combination 1350 speed, with 16, 26 and 36 well speed is taken. Like this in the 18 also we followed by that. Like that we have to full factorial 9 experiment done by this yeah, and we compare with that the base material, what is the material impacts on the tool profile on this well. This is the working flow chart. So first we have to go for this friction stir wheeling, and the basic things we had collected that. One is the material selection, that is very important for this what we experiment, why we are doing for that one. So 8011 the aluminum we are considering, and then tool also is there, and tool profile also is very important for the friction stir welding. And then weld parameters also. In that weld parameters we considering the 900, 1350 and 1800. There is a specific why we are taking this, means the some optimization getting the speeds like that low temperature to high temperature. So aluminum Li is withstand up to 2000 rpm. The less than 2000 rpm is gives the better. So on that average of that 900 and 1800 and middle the 1350. So these are the three speeds we taken by this one, and then go for that is the friction stir welding, and then go for the characterization, and then we discussing about that results. Right after that friction stir welding is completed, and then we go for the wire cutting machine, and then as per standards we cut by the specimens, like that is a tensile strength specimen, that is a ASTM E8 standard is followed by here, and then impact test, and then microstructure models. Like the 999 experiment we done, and the characterization also we go for this 9. Right, go for the results. Tensile strength, the condition is gets data maximum at. This is a S1 to S9. This is the idea of the S1, S2. That S1 is goes for 916 mm well speed, and then tool pin profile we can go for that. So this combination of 9 with compared to the base. So the base is the material is gives, that is the maximum, that is the 117 without weld, and then a weld condition of 1350, that is 26 mm per minute, that is gives, that is a 80.87 megapascal is compared to the base material is nearby. So after the welding also we are getting, that is the same strength, we can say that, and minimum is getting, that is a 71.62, that is a S5. Now this is the optimum microscope is given, that is a microstructure and microstructure. The macrostructures is gives, that is a the front evaluation, that is a nugget zone, thermomechanical heat effect zone, heat affected zone, and base material. Right, we can go for this the first one, that is the base material structure, but it is not clearly observed in this the optical microscope, and then we can go for that is a SEM. So there is a structure grains which are clearly visible in this comparatively optical microscope. So then base material, this is a bigger grains is appears, that is a heat affected zone, and this is the thermomechanical heat affected zone, and E is, that is a nugget zone. The fine grains is appears in that nugget zone, means that is nothing but weld zone. Now it is the same. It is clearly observed that this same specimen, it gives that is a clear microstructures. The first one, that is a clearly the bigger grains is appears, that is a base material, and then structured grains is appears in, that is a heat affected zone, and then mixed structures is appears in, that is a thermomechanical heat affected zone, and finally the nugget zone is gives, that is a fine grains in the appears.
2 minutes remaining, sir.
Now it comes to the hardness of the material, that is compared to this shows, that is a macrostructure, and that hardness. The hardness is the maximum at nugget zone in at value of that in that the different nine is appears here, 9 specimens in that. From that is a S5 it gets more maximum, that is a 30 HV, that is a micro hardness is compared to base material is 40 mm. So 30 is the hardness it gets, means it is also getting the nearby that is a base material hardness. These are the impact test. The impact test specimens is appears here in the photograph, and then the base material is 34 joules is appears, and that our experiment we then showed that is the maximum is 28, but it is less than base material that is a 34%. So all the mechanical properties gets that less, but because of we are going for the joining purpose, when it is joining, it is that annealing process is happen. Due to of that, that is a mechanical properties appears very less compared to the base material. And these are the conclusions. Right, the joints is appear the square pin profile that is 1350 and 26 mm per minute. They had a better tensile characteristics by using this. And then the fine grains is appears in the microstructure in nugget zone, and then goes for the hardness values are highest in that S5 experiments. These are the references. Thank you.
Hello. Nice work and a lot of experiments you have done.
Yes,
I appreciate that.
thank you, sir.
So, if you go back to slide number, micro hardness. Yeah. So, what are those black squares?
This is the S1 tools. S1 specimens. S1, this is the 916.
10 are there. I think one you have missed the nomenclature.
Star is also there, the last one.
Yes, sir.
Is the 3.6.
The base material is missing here. 9 is
Okay.
the
Okay.
base. The square is a little bit up and down.
But why it is deviating from others, the micro hardness, and which region it is deviating?
It's a one thing we can say that, sir, that is a well joint is very sound, and that is a it a nugget zone, sir. Due to of that microstructure is says that the fine grains is appears all pitch relation. On base of all pitch relation, we can say that we will get good hardness. This reason we can say that, sir, this 4-5 points is gets that is the maximum. It is the well zone. This is the well zone. We can appear like this. This 0 is between the two plates.
Okay. So where is the hardness? Sorry, do you have failed tensile specimen photos?
No, sir. 9 also very. After the tensile testing, we are not taking the photos, sir.
Didn't analyze.
Yeah, we will not go
Where
for the
it was
fractures.
breaking actually.
This welding zone only, sir.
It's not supposed to. Okay. So if you compare the tensile strength, there is no much difference, right?
Yes, sir.
Almost all it is negligible.
Yeah.
How can you say that one of the parameters is much better?
Sir, base material is 117 megapascal of this without welding. Now we compare the maximum. So when it is getting a smooth or good flow rate of the material mixing by the tool profile, we will get that high strength, sir. So base of that wise, we have to give the importance to the profile of the tool.
Okay. Thank you.
Okay, thank you so much, sir.
From audience, is there any doubt? Any queries? Yeah.
All these, as per your this one, the highest RPM and the highest traverse speed are giving the best this one.
On base, no, sir.
Isn't it?
That is there is a different.
What are your transfers speed, sir?
That is the 1350 is a RPM, sir.
That is the highest one.
Highest one. That is a spindle rotation, sir.
Hmm.
And tool is that is a 26 mm per minute. So the
That is
weld
also highest or
medium, sir. That is also medium.
what are the
36
traverse?
is the highest, sir. 36 is the highest.
Oh,
Yeah, here is given that is the
36,
param. 36 is the highest.
16 to
So there is a
done. So middle one it is giving good.
middle one is giving the best values by this tool. On base of the profile, if it can change the speed and feed.
Now my base question is on what parameters or on what this one you have finalized the speeds of, say I want to take, or we want to take 900, 1350 or 1800. Is there any basis for that?
Yeah, I can recommend it by my experiments. We can go for that is the 1350 the spindle speed.
No, okay. As per the experiments, 1350 and 26, you got it as best.
Yes, sir.
But on what basis you took 900, 1350 and 1800?
Yeah.
Why 900 first?
Right.
Why can't 600 or why can't 1000? Why?
Yes, basic thing is that is the melting temperature of aluminum alloy is 1660. So on base of that, above that, so when we are going joining of the two materials by using of this third body of this tool, and friction is generating due to of mechanical action is appears in that is the three plates. So in base of that, we joining that material by the below the recrystallization temperature. Due to of that, we require the joining of the two material. A minimum temperature requirement is there. So we can go for the speed, feed, and the ratio, the metal can be joined, sir. So that way, on that previous scholars' references, on base of that, the minimum we are taking that is the 900 RPM, and maximum is actually we can go the high speeds also. But what happened that is the material will be scratching from the weld joints. So we more heat, more analyzing and getting temperature, or though it is a metal joining is weak. That's why we have going that is a medium temperatures to weld joints.
I have one more question.
Sir.
As sir asked and you gave one answer and sir said how. You said your tensile specimens broke
Yes,
after
sir.
the testing,
Yes, sir.
and they broke or failed at the welding zone. Are you sure?
Yes, sir.
If they fail at the welding zone, that means the welding is weak.
Yes, sir. Compared to the original material and then weld material is always weak, sir, compared to the base material to the weld joint. The
So
welding
compared to
always
base
is
material, welding is weak, and that's why it is breaking it.
But it's a base material you can change for like that is a zinc, some other materials. You can go for that. That joints will be more in that is the weld zone, and then we get that base zone.
Okay.
Okay, so I think it will be 5 minutes for question and answer, but I have only one
Sir.
doubt. It is there in the figure 5.
Yep.
So because figures will give more type of doubts. Okay, so figure means that chart graph 5.
Oh,
Yeah,
okay.
here
Okay,
it
sir.
is. Okay, so coming to between between 0 to 5, it
Yes,
is
sir.
started going in the parabolic shape.
Yes, sir.
Okay, and it is ending and converging again in 25. Okay, so between 5 to 25, is there any application background? So where your metal will be used for particular application, where initial stress will be more. So what is your metal application background? Research.
I want to find out this.
Yes, yeah, because we can easily means
The-
testify the thing is actually the other base materials will go like this for this application. So
Okay.
initially high strain will be there for that application.
Yeah,
So it
exactly.
will be in aerospace or automobile or
Yes, sir,
whatever it may
that's
be. So then you have done some work to reduce that strain, means reduce the stress. Okay, in
sir.
between 5 to 25. So that you need to, I think,
Okay,
look
sir.
on this application background.
Thank you,
Thank
sir.
you.
I will find out. Okay, thank you, Ananda.
Thank you, sir. The next paper is by Dr. Nagakishore Surisetti with the paper ID 38, titled Influence of Climatic Parameters and Dust on the Performance of 40 kilowatt grid solar PV system in Kavali, India. Yes, sir.
A very good morning, one and all. Very good morning. My paper title is Influence of Climatic Parameters and Dust on the Performance of 40 kilowatt grid solar PV system, which is installed in DBS Institute of Technology, Kavali, which is my native place actually. The main reason to do this work is that we have two reasons. First one, we have received a complaint or problem from the college management. Um, they were getting more power bill in the years 2021 and 22 due to dust. So how much power was reduced, they wanted to know that. That's why they have given one problem to me and to us. So we did this work. That is one reason. And second one is that when we conduct an experiment or a performance test on solar PV system, that will be very useful for making better designs in the future. So what problems generally we see inside we can identify. So that problems will be rectified in future. That will be giving better performance and for better maintenance case. So these are the main two reasons to do this work. So objectives wise here, we estimated the actual performance of solar PV system for 40 kilowatt installed in an engineering institute and for 1 year duration, January 2023 to December 2023. And we also investigated what are the influencing parameters. Mainly we concentrated climatic parameters, ambient temperature, humidity, and cloud cover, how they affected the performance of PV system. That is one of the objectives here. And the dust content, what we have on the solar panels, how it is affecting the performance of the PV system, it is also one of the major objectives here. So this slide mainly tells you why these solar PV grid systems are important for Indian power sector. This slide will give us information. So actually, from the Central Electricity Authority, we observed that 452.69 is the actual installed capacity till now at the end of November 2024. So the power deficit value was identified 3,340 megawatt at the end of November 2024. This is very, very big value. Total installed capacity case, this is less, but when you see in actual conditions, this is a big value. And so along with that, one more important problem what we are facing now, in India, majority amount of power is mainly coming from coal-fired power plants, and Central Electricity Authority has given report that in coming 2 years, 22,716 megawatt is going to be retired due to various reasons like not maintaining the space for FGD systems, are not following the guidelines of Ministry of Environment and Forest, and age limit, because most of the power plants were built in the period of 1970 to 1985. So because of that reason, they have already crossed age limit 40 years. So in coming 2 years, we are having a very big shortage in case of power. So India Energy and Climate Center also has given report on this one. In 2027, we are having big power shortage. That value also was given in the range 20 to 40 gigawatts. So to reduce this problem, we need to install more amount of power plants in India. Better alternative for reducing this problem is that renewable energy sources. In this, mainly wind and solar are best options. Compared to wind, solar is again best option. Why? Because more amount of time you will be getting. Both are intermittent, but compared to wind, solar is better. And particularly in solar, we have two types. One is solar PV systems and solar thermal system. In solar PV, again, we have grid and off grid. Particularly in total solar, grid connected solar systems are better one. Why? Because of less maintenance, so less cost and long life. So that's why we have selected grid connected solar system for our study. So for performance test case, there are different parameters which are influencing the performance of PV system. So this slide gives us what are the major parameters are influencing, and radiation, environmental parameters, shade, cell temperature, tilt factor, tilt angle, like the different parameters. Mainly we have concentrated environmental parameters in which we see high humidity, ambient temperature, cloud cover along with dust. Here, when humidity value increases in the atmosphere, that humidity reflects and refracts the sun light. So based on that, the radiation value which is placed on solar panel will be decreased. So finally, humidity reduces the solar panel performance. That is the main thing to be observed. And one more thing, ambient temperature, when temperature value increases in the surrounding, more radiation will be placed on the surface panel. So more heat will be absorbed. Finally, power and efficiency of the panel will be increased. And cloud cover also absorbs sunlight and reflects sunlight. So the radiation value will be impinged on the panel decreases. So performance value decreases. Dust here, dust also absorb, and it is not going to reach the solar radiation because of dust. So performance value will decrease because of dust. So this is a literature what we have observed from various authors for these performance parameters. Uh, for humidity, I have given this. We have given this table at different places and different capacities. How the performance was reduced. This slide will give us information. And this is dust information literature review, and various dust particles they placed on panel. How performance was reduced. This slide will provide us information. But when we see these literature reviews, mainly majority amount of literature was mainly carried out on small plants, means 2 panels, 3 panels, like that they worked out. They didn't go for large capacity or high major plants because of so many permissions we required. So that's why we didn't get much information regarding these grid connected systems for particular on climatic parameters case. But our work mainly is concentrating on grid connected large capacity system, 40 kilowatt system. So this is our solar PV system, which is installed in DBS Institute of Technology. The location has mentioned on the other side, Kavali, which is very near to sea, and where generally the temperature, ambient temperature value varies 29 to 38 degrees Celsius in year, humidity value 60 to 80%. More cloudy days we see in the month from period of July to September or October up to that, and less cloudy days we see in January to March. And the plant was having tilt angle 10 degrees here, and total 160 modules we have placed in that. 80 modules were connected to one grid inverter, and remaining 80 modules were connected to another grid inverter. Total 2 grid inverters are located there, and this DC is converted into AC in grid inverter. After that, it will pass to energy meter, then finally it will go to grid. So these are the different performance parameters. Mainly output value will come from the plant. So by using these equations, we can measure actual performance. These are the different performance parameters: inverter efficiency, module, system, and performance ratio and capacity factor. So when we go for results and discussions here, the annual performance of PV system is mentioned in this slide. So annual performance was varied from 12 kilowatt hour to 210 kilowatt hour in the year 2023. The maximum power we have received on 12th April 2023, which was 210 kilowatt hour. And minimum value was observed in the December 4th, 2023. Why particularly these maximum minimum values here? Climatic parameters playing a key role here. So when we see on 2023 April 12th, on particular day, we have very, very less cloud. Only 1% cloud data we have got, and temperature value was reached 34 degrees Celsius. But when you go for December 4th, 100% cloud, completely the day was cloudy, and the humidity value was reached 94%, and temperature is very, very less, 23.4 degrees Celsius. That's why we have got very less power value from the plant. And this is total annual performance of the PV system from January to December. And major amount of power we have received in the month of March, and minimum power we got in the month of December because of climatic conditions. And yearly performance we have, in case of performance ratio, we have got 75.46 annual performance. And the plant efficiency is 12% average, and inverter efficiency is 97.46, and system efficiency is 11.68 for total year. But this value varies based on the capacities and based on systems what they maintain properly. And when you see the comparison, the effect of these parameters on PV system, when humidity value varies, if you observe, the fit line shows clearly the performance of PV system is coming down. And the cloud cover value increases, and at the same time, the power output of the plant is decreasing. ambient temperature is increasing and the power output value increases. If you observe carefully, the R square value, the fit line value is not coming in good way. Why? Because these readings were taken under real situation. So many parameters are acting on the solar panel. Temperature and cloud and humidity all are acting on the same time. That's why it is not possible. When you go for artificial experiments case, we can maintain one parameter as vary and other parameters we can keep as constant, but here it's not possible. So many parameters will act on the panel. That's why the relationship has not come in good way.
So last 2 minutes.
So this is dust effect. For 31 days, we conducted experiment on dust. Mainly what we observed that the plant was located on fifth floor. Um, very less sand particles was accumulated on the plant, but majorly we observed that bird droppings. Birds placed there, bird droppings was the main problem in that area. So that's why gradually the performance of the plant was decreased. And in total 31 days, we observed that 13.9% reduction average we observed in the plant. So this is on 15th day what we observed, how many bird droppings we got on the panel. On 31 day, if you see, huge amount of bird droppings were placed. That's why on 31 day, on 31st day, we have got 25.9% reduction in power. When you see on 15th day, we have got 18.7 something reduction in power. So for these 20 kilowatt panels we kept in clean way. Remaining 20 panels we neglected, we didn't clean. So continuously on that panels, birds were going to droppings. So conclusions here, we investigated the performance of 40 kilowatt grid solar PV system. We identified a relation between climatic parameters and performance. And finally, what we observed that cloud cover was playing a key role in Kavali zone in these three parameters: humidity and temperature and cloud. In these three, cloud was playing key role to affect the performance of PV system, because we had a strong relation between these two. After cloud, we have temperature and later humidity. This is the level of going. And when you see the dust content wise, dust having a significant playing a significant role on the performance. So due to the dust, we have got 14% reduction approximately for 31 days in that period. So this report already we have submitted to that college. So they planned that they did some modifications. Now they are maintaining regular cleaning, and they are satisfied. In future, we are going to take readings for coming 5 years, and we are going to prepare an empirical correlation for the climatic parameters and power output that will be useful for particular zone. So these are references what we maintained in the slide. Yeah, thank you, one and all.
Thank you, Mr. Nagakishore. Your presentation skills are very good, the way you have presented. But coming to the article, you have presented only 2 slides on the dust, right? Mainly introduction, you said that it will be on the dust particle. So how it is affecting is fine, but what is the solution? That you should have focused more, right? And based on the layer thickness, is it how the efficiency is varying, like dust layer thickness? So you said bird droppings had effect on the efficiency. So how can you prevent that, right? And cleaning that is not an easy thing compared to dust, right?
Yes.
So some solutions you could have presented here instead of, like, everyone knows what are the problems, but solutions are expected, right? Thank you.
Any other questions from the audience? Okay, I think from my end, I have one question, like similar to the sir's given. So you have done any experiments there, sir, actually, in Kavali and that station? You have gone through any experimentation? So some
Yes, sir.
study.
Yes, yes.
Your collected readings.
Yes, we have
Okay,
collected
okay,
data
okay.
for every 15 minutes in a day.
Yeah. Okay. So I think that whatever the burst thing is there, no? So what will be the and the efficiency? You have calculated an efficiency of the plants, the total plant.
Yes, yes, sir.
So
Plant
you have
efficiency.
included the maintenance cost. Maintenance cost.
Maintenance cost.
Yeah. So what are the efficiency when you're calculating power efficiency only you calculated or not overall plant efficiency?
So plant efficiency also we calculated.
Then
That
you
is 12.
removed the that maintenance part because that burrs and everything is there. No?
Yes,
So we
sir.
need to clean
Actually,
every time and some power we need to utilize for that purpose. What are the generated
so
power?
regular maintenance is required, sir. Actually,
Yes,
regular
yes.
maintenance required. Actually, they forgot that.
Hmm.
Like we given a suggestion to that regular maintenance every for 4 days we need to clean that. But
Yes.
actually, what sir said is exactly correct.
Yes.
Maintenance is not a simple thing.
Yes.
But we given clear instructions to that. We have to clean regularly.
Okay,
But
you are giving clear instructions. My question is how they are cleaning. So is there any machine it is
no, sir.
using for
Only
cleaning? So
manual
manual
cleaning. Manual
only.
cleaning.
Okay. Then for them they need to pay something, no?
Actually, college persons will be there. They go
Just
and
free
they
of
clean,
cost
sir.
they are
Yes,
cleaning.
yes, sir. Actually. Yes, sir.
Okay. I think you need to go. Yeah. I think okay. Thank you.
Sir, actually, one more thing. That's correct. But here the problem is that in colleges face particular. Maybe also study said that the inclination angle of the band up to 20 angle we have 1.5 pounds. 20 to 60 degrees in the solar panel, we have another performance. More than 50 to 90 we have, but results mainly said that 20 to 90 degrees for solar panel. That's the amount of stimulation will be placed on the ground. But that is not preferable actually. When you see sufficient radiation will not be now, sir. Yes, sir. I agree, sir. Yes. Yes, yes, yes. Yeah, thank you, sir. Thank you very much. Transparent means we have to maintain a transparent glass, because that has to be absorbed. I mean, that has to pass the solar radiation onto the surface. So that will be again a difficult for maintenance.
That also could be bird dropping.
Yes, yes, yes.
I think, sir, whatever you are saying is a use and throw type. It is okay working. So, what are the material cost for that film? Film, you are asking film, not glass. Glass is very costly. Yes,
And that glass should be transparent. That is
transparent.
important.
So, definitely there is a loss of energy.
Yeah,
Okay.
yeah.
Thank you, sir.
Yeah, thank you very much. Thank you.
We have our next presentation by Mr. Ramesh via online mode. The paper ID 36 titled Evaluation of Mechanical Properties of Friction Stir Welding for Aluminum Alloy 7475-6061 and Copper. A small note, in place of Dr. Madan sir, we have session co-chair Dr. T. Krishnaya sir. Krishnaya sir is working as associate professor in the mechanical department of Anurag University. He is serving as chairperson BOS. Sir will be co-sessioning the chair. Sir, we welcome you. Thank you. Online presentation.
Hello. Hello. Sir, ఉన్నాను సార్ లైన్
Sir,
లోనే
Ramesh
ఉన్నాను.
sir, are you there?
కనబడుతున్నాను సార్ నేను.
Ramesh sir, are you there?
Hello. Sir, good afternoon all of you, sir. Hello. Good morning, sir, all of you. Sir,
Sir, could
audible my voice, sir.
Could you please speak a bit louder?
Hello.
A bit louder, sir.
Hello. Sir, audible my voice, sir. Hello.
Sir, you are audible, but your voice is a bit low, sir.
Sir, now, sir. Hello. Hello. Sir, audible my voice, sir.
Sir, yes, we can. You go
Hello.
ahead, sir. Start the presentation.
Sir, is it audible my voice? Hello.
1 minute, sir. 1 minute.
Mr. Ramesh, are you able to hear us?
Yes, sir.
Yeah, done. Now you can start presentation.
Okay, sir. This is Ramesh Kanugupenta. I am from Mechanical Department, WEMO Institute of Technology. So today my topic is evaluation of mechanical properties of friction stir welding for aluminum alloy 7475 and aluminum alloy 6061 and aluminum and copper composition materials. The next slide, sir. Hello.
Yes, sir, you can continue, sir. Yes, sir, continue.
So this is so here the following contains abstract literature, research gap, objectives, experimental setups, results and discussions. Discussion by further slides. So the main abstract of my research topic is friction stir welding is a solid state joining process that has gained increasing interest in recent years due to its ability to join dissimilar materials with high quality welds. The materials such as aluminum and is fast becoming the process for choice of manufacturing light and transport structures such as boats, trains, aeroplanes. So friction stir welding overcome many other problems associated with the traditional joining techniques. So in this, my research work is we are going to done by frictional stir welding materials like aluminum 7475, aluminum 6061, and aluminum and copper composition materials. So in this aluminum copper composition and aluminum alloy for workpieces and cutting tool materials. So here using high carbon steel materials and cutting tool speeds approximately 8,000 and 10,000, 12,000 RPM, and welding speeds are approximately 30 and 40, 30 mm per second. So in this my present work is We will go to evaluate the mechanical properties like tensile strength, compressive strength, impact strength, and hardness by using above following materials. So, hello. Hello.
Yes, sir. Go ahead, please.
Sir, could you please change slides, sir?
Next slide. Literature review, sir. Sir, you can go directly to your work, sir.
Okay. So then go for literature review. So here, name of the author, Jayashree. Here of publication 2021. The title of paper is Indivisible and Combined Effect of Reinforcement on Stirred-Cast Aluminum Metal Matrix Composites. So here the main outcome of this title is the mechanical behavior of the welded composites underwent equivalent modifications that relieved these variations in microstructures. So here the find out mechanical properties and behavior of mechanical properties and microstructure. So in this author, and again Vijay Swaminathan. So here the era publication 2020. So here the title of investigation and mechanical properties of aluminum 6061 metal matrix with boron carbide and graphite. So here also to find out metal matrix composites like mechanical properties and analysis of effects of the reinforcement of the mechanical behavior of the aluminum 6061 and metal matrix composites. So finally, the research gap is the main research gap is after study of literature review of the following gap is identified. Most of the authors have calculated and tested to find out the mechanical test behavior and properties. So in this present, my research work is done by friction stir welding on following materials like aluminum 6061, aluminum 7075, and composition of aluminum and copper materials. So the above similar materials are used to make a strong joint by using friction stir welding. After welding of materials, going to conduct a different mechanical test and find out the mechanical properties and behavior of materials. So this is the, I have find out the research gap of whenever I am studying of literature review. So the main objectives of friction stir welding, my research work is we are going to friction stir welding done by following materials like aluminum 7075, aluminum 6061, and aluminum copper composition materials. After welding of materials, going to conduct different mechanical tests and find out the mechanical properties and behavior of the materials. So this is the experimental work. There is no some copper, aluminum and copper composition material, aluminum 601 material, and aluminum 7475 alloy materials is friction stir welding applied done by specimens as shown in figures in experimental work on this slide. There are slides to can you please show the slides, sir? Hello.
Yes, sir.
There is no visible from my side, sir. That is the problem.
Which slide do you want, sir?
Experimental work, sir. Experimental work.
Yes, it is visible, sir. It is on the screen. You're good to go. Please speak a bit louder, sir.
Okay. So this is the FSW specimen geometry of aluminum and copper composition, aluminum 6061 and aluminum 7475 alloys. So as shown in figures in experimental work slide, and whenever we done by friction stir welding on the above materials, we have made a specimen. We have made a specimen when we are going to conduct mechanical properties by using universal testing machine and impact strength. We have find out impact strength, HRPI jot. So we can made a specimens. So as shown in figure in experimental work slide. So there is a specimen is here, and So this is when I am going to discuss about results and discussions. So we have find out ultimate tensile strength. So here dimensions of specimen is there. The length of the specimen 130 mm, breadth 15 mm, and thickness 5 mm. So here find out for aluminum 7475 alloy from universal testing machine. So breaking load is 6.8 kilonewtons. So and cross sectional area 15 into 5 75 mm square. So now tensile strength equal to breaking load by cross sectional area equal to breaking load by cross sectional area. Then after getting universal tensile strength 91.733 Newton per mm square. So same way we have find out aluminum 7475 and aluminum 6061 and aluminum and copper composition. We have find out ultimate tensile strength 91.73 Newton per mm square in aluminum 7475 alloy, 96.00 Newton per mm square in aluminum 6061 and 112 Newton per mm square aluminum and copper composition material. And yield strength, we have find out yield strength 77.33 Newton per mm square and 80 Newton per mm square and 97.33 Newton per mm square respective for materials. This is the graphical representation of yield strength and tensile strength. So in this yield strength and tensile strength, we have find out copper yield strength is getting more effective.
You have one more minute, sir. Go ahead, sir. Go ahead. One more minute.
Okay, sir. We have only yield strength is getting 97.33 more, and the lowest yield strength getting for aluminum 7475 77.33. And tensile test we are getting more copper is 112, and aluminum 7475 is getting lowest tensile strength of this specification. So after getting this is the specimens when we are conducting for tensile strength and yield strength of these materials. So then after going to hardness test, so here the following test we are going to conduct these materials. Here we are getting. So here we are getting major amount of hardness is 90 hardness from aluminum copper composition. Least is aluminum 6061. So here mean radius. So then go for impact strength. So this is dimensions of specimen, length 54 mm, breadth 15 mm. So then we are going to conduct this experiment. Finally, we have getting following impact strength Newton per mm square. Major impact strength is getting 38.66. Aluminum 6061 is getting major impact strength, and lowest impact strength is getting aluminum copper composition material. So this is hardness. Hardness test we are getting aluminum 6061 is major amount of hardness is getting, and lowest is aluminum and copper composition material is getting. So and impact strength we are getting 38.66. Aluminum 6061 is getting, and lowest impact strength is aluminum copper composition is getting. So finally the conclusion of this here in this ultimate tensile strength, aluminum and copper composition exhibits the highest universal tensile strength and yield strength 112.5 Newton per mm square, and aluminum 7475 was the lowest value. And compressive strength, aluminum and copper composition achieves the highest compressive strength 153.6 Newton per mm square, significantly aluminum 7475 which is lowest getting 93.33 Newton per mm square. In the impact strength, aluminum 6061 highest impact strength is 38.66 Newton per mm square, while aluminum and copper composition has lowest 35.73 Newton per mm square. In this hardness test, we have find out highest hardness is getting aluminum 6061 alloy, and aluminum and copper composition shows the lowest at 52.5 Newton per mm square. So the main feature scope of uh, this project is this research work is the friction stir welding process parameters and specifications to design components and structures and incorporate the joining of aluminum copper composition and aluminum alloys. So this is mechanical properties of the welded fans under various loading conditions. So this is the main important references. So thank you.
Yeah, hello, sir.
Sir.
Thank you for presentation. And now our session chair will speak to you, sir, regarding the questions.
Okay, sir. Thank you.
Hello, Mr. Ramesh.
Sir, tell me, sir.
So which standard you have used for tensile test?
Universal testing machine, sir.
No, standard. Any ASTM standard have you followed?
In this, in my laboratory, we are using for universal testing machine, sir. Here.
No, what is the specimen dimension? Can you tell me what is the shape and specimen dimension?
The flat pieces, sir. Flat pieces. Dimension approximately 5 mm thickness, sir. Thickness is
no this
each and every experiment. I mean, a universal testing machine. We have using some amount of shape and size, and here impact strength. We can made an some shape and size of the material, sir. Approximately.
Okay, and
impact strength, the length of the
okay,
specimen
it's
is
okay. Come to the last slide. What is the unit for hardness? Why it is Newton per mm square?
Not mentioned, sir.
Which testing machine you have used?
Yeah. Sorry, sir. There is no hardness units, but here mentioned, sir.
Okay, thank
you. Sorry, sir. Only for hardness test, there is no units here, but I mentioned.
Yes, sir. One more question from audience, sir. Please ask.
Sir, you have mentioned the dimensions for that is a welding area or total specimen length. One more thing, you have not mentioned the throat thickness here. Length and width thickness you are considered. That is for that like welding zone area or total specimen object.
Only welding zone area, sir. Welding zone area.
But you have not mentioned the throat thickness here. You have not find out any.
But here I mentioned thickness 5 mm is total thickness of the material, sir. Total thickness of the material.
There is a thickness of the specimen or the welding zone thickness that you can.
Total thickness of the material, sir.
Throat thickness is 5 mm.
Length of the specimen 130 mm, the breadth 15 mm, and thickness of the material 5 mm.
Any more queries? Thank you, sir. Thank you, Ramesh, sir.
Okay, thank you.
You can log out. Now let us break for tea. And please be assembled here within 15 minutes.
వినపడుతుందా? వినపడతలేదు నాకు. నా వాయిస్ వినపడుతుందా మీకు? మీ వాయిస్ వినపడతలే.
ఎస్ ఎస్ ఇప్పుడు ఓకేనా సార్?
వినపడుతుంది.
మీరు మాట్లాడండి, మీరు మాట్లాడండి.
వినిపిస్తుంది కదా మీకైతే?
వినిపిస్తుంది, వినిపిస్తుంది.
రైట్ రైట్. ఓకే.
ఓకే ఓకే సార్.
టీ తాగుతావా?